Hi, today I will show you an example how to design a spiral circular column which is subjected only to axial load. We have dead load to be 210 kips and we have live load of 300 kips. So we are assuming that 2% of longitudinal steel is equal gross area of column. For this column, we have compressive strength of concrete to be 4,000 psi, and we have a yielding stress to be 60,000 psi. So what we are doing first, the first step will be to determine the axial load using the safety factors for dead load 1.2 and for live load 1.6. So with our numbers, we have 1.2 times 210 plus 1.6 times 300, which will give me factored axial load of 762 kips. So 2% of steel, that means the area of steel is 0.02 times gross area of column. And the next step will be that PU is equal phi P naught. For spiral columns, we are using for phi 0.75. So our PU will be 0.85 times 0.75. Then we have 0.85 for our compressive strength. We are using 4,000 psi. Gross area minus 0.02. Gross area instead of area of steel plus 60,000 for yielding stress and times 2% of gross area of the column. So since that our PU is 762 kips, and if we are plugging our numbers, we will obtain that gross area of column has to be higher or equal to 163 inch square. So circular column, we have that gross area is pi over 4 times d on square. So using our numbers, we will obtain that diameter is 19 inch. So it is higher or equal 18.32. So we will use 19 inch. So new gross area will be 19 on square times pi over 4, which will give me 283 inch square. Steel area will be 2% of 283, which is 5.6 inch square. So we can pick number 9 rebars, which is 6 inch square, and our primary steel will be number 9. So now we need to determine the secondary steel and the spacing or the pitch. So firstly, we need to determine what will be the core diameter. If you are using for concrete cover 1.5 inch, our core diameter will be 19 minus 2 times 1.5, which will give me 16 inch. So cover is used according to the table ACI code 20.6.1.3.1, and this will be the cover. Here we need to determine the spacing or the pitch, and according to this, core area will be pi over 4 times 16 on square, which is 201 inch square. Spiral loop has to be made of number 3 because we said if we have the main rebar size number 10 and lesser, we will use number 3. And for number 3, we have that steel area is 0.11 inch on square, and diameter of the rebar will be 0.375 inch. And for spiral or circular columns, we are using the equation that rho S minimum is equal rho actual. For rho S minimum, we have equation 0.45 gross area over core area minus 1, that is in parentheses, times 4,000 for compressive strength over 60,000 for yielding stress, to be equal 4 times stirrup area, which is 0.11. Then we have core diameter, which is 16, and minus diameter of secondary steel, which is 0.375. All of this we are dividing by S times diameter, core diameter on square. So when we are using this expression, we will obtain that our S is 2.20 inch or very, very close to 3 inch. So according to this, we have that diameter of the column to be 19 inch, cover is 1.5, core diameter is 16 inch, main rebar area will be 6 inch square, and for spiral bar we have number 3, and we have steel area to be 0.11 inch square and spacing to be 3 inch. So this will be the example for circular column, and in the next video I will show you case number 2 when column is subjected to axial load and moment. See you guys.